There we go. All right, we have Chris McDonough here. He's going to talk about API design for libraries. Chris.
Hello, everybody. Wow. Did somebody pay for that?
You will later.
I will later. All right, so my name's Chris McDonough. I am a consultant at a consulting company named Agendaless Consulting in Virginia. And I'm going to talk about API design for libraries. This talk is just mostly going to be me ranting about bad design, more or less. But I hopefully, I don't mean to rant entirely. Hopefully you get some useful information out of it. So I came to Python through Zope in about 1999 or so. I've authored the Pyramid Web Framework, Supervisor, Unix Process Controller, and a bunch of other things that I'm less proud of. And so I'm going to give this talk, and I just want people, I'm sure I'm going to step on somebody's toes during this talk. I don't mean to do that. I care about your feelings. How can you tell I'm lying? And if I use code for one of your projects, it doesn't mean actually it means I use it. So it's it would be worse if I didn't. So I'm going to talk about three kinds of things in this talk. Well, this talk is mostly about libraries, but there are three different kinds of things that have strangers using code that you might write. One is an application. And an application is something, in my mind anyway, for the context of this talk, an application is something that can use global state with abandon. A database is global state, okay? Module scope stuff is global state. A framework is sort of a step down from that. It doesn't have, usually frameworks have no state, but they call into code. You provide them callbacks that they call into, okay? A library is neither of those things. A library is something that you call in order to have it do something on your behalf, all right? Usually libraries maintain little or no state. They're not stateful, they're just sort of tools. And they don't have any callbacks. This talk is mostly going to be about libraries, although I'm going to probably venture off into framework land at some point. So the things that I'd like you to take away from this talk are 4 guidelines. These are things that sort of, I think are important. They're not the only things you need to know about API design, of course, but they're sort of bred from annoyance on my part of my own code and seeing other people's code. If you follow these guidelines, hopefully your code will be useful to strangers, not just the people who sit next to you or the people you talk to on IRC, or people who actually need to use your code who do not know you, don't know your name, don't care who you are. This is the point of this talk. And the importance of these guidelines increases with the social distance that you have from those people. So these things aren't all that important when you're sitting next to the person using your code, but when you're not sitting next to the person using your code, they can be important. So here are the guidelines. The first one is global state is precious. All right? Global state is module scope state in a Python program. The second one is don't design exclusively for convenience. Third one is avoid knobs on knobs. And the fourth one is composition usually beats inheritance. And I'm going to talk about each one of these things. So the first one we'll talk about is global state. What you're going to want to do when you write a library is you want to avoid unnecessary mutation of global state. Mutation of global state happens when you type something at module scope in a Python module, and that module gets imported or executed. So a class statement or a function statement is actually a mutation of global state. You're changing the state of the Python process by doing that. But when you require that other people mutate global state in a way that they wouldn't normally to use your library, or when you depend on reading some global state in your library that they wouldn't otherwise have to read, it sort of becomes less of a library. It's more like an application. And we'll see some examples of this. So one example of this is in the multiprocessing library, in the standard library. Who here has used the multiprocessing library before? Okay, lots of people. So when you import the multiprocessing library, this little @exit thing at the end of this slide is run. And it says @exit register this exit function above. And what @exit is it's something that will get executed when the Python interpreter shuts down. Regardless of anything else you do, it's going to get called. Okay? So this happens when you import the multiprocessing module. So the mere import of this module causes this @exit function to get registered. This @exit function cleans up, tries to do some cleanup at the end of the process. Okay. Another one is from the logging module, which does a similar thing, but it tries to clean up handlers. And handlers are things that push stuff into loggers. So why are these things bad? Well, they're not bad. You know, they could be better. You know, when you do this at module scope in your code or in standard library code, it doesn't matter whether somebody intended that to happen, intended that @exit function to get registered at the end of it. It's going to get executed, or it's going to get registered regardless. So the mere import of the multiprocessing module is going to cause that @exit function to get registered. But that's actually unnecessary at this point, because if you're actually not using multiprocessing, you just happen to import multiprocessing, there will never be any state to clean up. There can't be. You haven't made any state in there. So, you know, I've run into this several times. I actually submitted a patch to Python that does some awful stuff to get around this in sort of unit testing cases. But it would have been better if this had not done that. I'll talk about why that's not feasible a lot of times, but in general, it's better if you don't sort of have registries at module scope. Here's another sort of variant on this theme, which is sort of mutating globals as a result of an object constructor. This is again from the logging module in the Python standard library. The Python standard library has these two sort of global registries, this handlers thing and this handlers list thing. And when you make a handler object, when you call this init constructor here, what it does is it actually puts a note in the handlers dictionary that says, you know, myself is present, and then it also appends the handler to this handler list, or it prepends it to the handler list. And it doesn't matter whether you intended to do this or not. The mere fact that you've actually made a handler instance causes this to happen. Okay. Async core is very similar. Async core has this concept of a socket map, which is a global. And if you make an instance of this dispatcher class, which is usually subclass from, it'll put this object as a value in the dictionary, in the socket map dictionary. Now, at least this thing lets you pass in an alternate map, so it doesn't always have to affect global state, unlike the logging thing. But still, if you make one of these and you don't pass in a map, then it's going to mutate global state. So what is wrong with that? Well, imagine that you want to actually use the logging handler class outside of the context of the larger logging framework, which isn't that weird of a requirement. I mean, sometimes you just want to, you know, there's valuable code in there. It's API code. It's actually documented as being useful outside of that whole framework. But it turns out that when you use it, when it does this stuff, and you go to write tests or do something slightly out of the normal way that the original logging author intended you to use it, you get sort of these weird side effects. You know, you get an error message when you shut the process down, or you get memory bloat as you make, you know, more and more instances of these things. So my suggestion for this is instead of doing this, what I would suggest to people that are making libraries like this is just don't do that. And if you need a convenience thing, to go ahead and sort of make the convenience thing on the side. You know, make the classes themselves useful, but then make the thing that does the registration at global scope something else that's not used at import time or at usage time, normal usage time. Because it just makes everything much easier. If you know that you're creating an instance of something, and you know that that's all you want to do, then you can test that all you did was create the instance of something, and you don't have to test for side effects or tear down this global dictionary at the end of your test. So Another sort of variant on this is calls for side effects. This is also from the logging module. I'm sorry, logging author. At this point, you import the logging module and you call logging basic config. And then you call logging add level name, whatever. Another instance of this is in the MIME types module. You import MIME types, you call MIME types init, which reads the etc MIME types file if you're using Unix. And then you can add types to it, but it's basically a global API. And another instance of this, if you're in e-commerce, uses Python Braintree Payment Gateway API, you're also impacting global state when you call this configuration function. Okay, these are all sort of anti-patterns. And what is really wrong with this? Well, if you notice, in every one of these examples, in this logging example, we don't care what basic config returns. We're just mutating global state. We're calling it for its side effects. The same thing in MIME types init. We're trying to read the config file, so we're just saying init yourself. You know, we don't care about its return value. And also for the Braintree configuration thing, we don't care about its return value either. So that's sort of fine, except who is meant to call it? When are they meant to call it? How many times can I call it? What happens when I call it for a second time or a third time? How do I test it? You know, this introduces a lot of confusion when you have things that are just called for side effects, especially when they're just at global state. So another minor anti-pattern, also from the logging package, is this raise exception. You know, this is at module scope in the logging module. Raise exceptions equal 1, and this is just kind of a flag. It's actually documented as an API, but how are you meant to change it? How would you change this value? Well, you would monkey patch the logging module. Is that a good idea? It's a terrible idea. It's an awful idea. But that's the API. There's nothing wrong with it if it's for the convenience of the developer, the library developer himself, but if it's offered as an API, it's just not really a great API to go monkey patch something that you've imported. You know, there's one of the reasons it's bad is that you can't have different configuration. If you have two things that use the logging module in the same package, you can't sort of use a different configuration of the logging package over here that you could over there in the same process. It's just impossible because everything's global. So another minor anti-pattern. Although this one isn't quite as bad as I thought it was. After I actually went to the Django conference in Washington a few months ago, and I was told that actually this is under control. But this Django has a settings.py module, and you are meant to put Python code in there that acts as configuration. Okay, so you put in these statements like debug equal true or template debug and all this stuff, and Django imports it on your behalf and uses it as sort of configuration values. Okay, there are a number of things wrong with this, which are this is a little less onerous than some of the other stuff. It's actually documented in the Django documentation that you should not import stuff from your application in the settings module. But you can. So you can actually say in your settings module, import something from my application, and then in your application, import settings. And at that point you wind up with a circular import that may or may not resolve depending on where the imports happen in the module. And for people new to Python, this is a extremely confusing error when they see this. They tend to bounce off of that error pretty badly. So it's good to avoid it for people new to Python. The other reason it's bad is that the settings are actually global. There's no way to have different settings. If you wanted to run two Django apps in the same process, you really can't. Well, there are ways around it, but they are really hacky ways around it. You know, sort of mutating module state, and you know the products that let people have like local settings and stuff or two Django apps in the same process are pretty hairy, and it would be better if you passed in the settings to the Django module. So, given all that, I've sort of ranted about what's not okay at module scope and what's not okay to to put in there. What is okay at module scope? Well, these, in my opinion, are the things that are okay at module scope. You can do a non-circular import of another module at module scope. Import OS. That's fine. You can assign a variable name in the module to some constant value, debug equal true or whatever. That's fine. No problem if you're going to use it later in your program. You can add a function by saying def foo. That's fine. You can add a class by having a class statement. And you can sort of pick and choose which of the four previous things happen as the result of some platform-specific flag. Let's say you want to define a class slightly differently if this is a Python 3 app, but if it's a Python 2 app, you want to define it a different way. You could say if the Python version is 3, then class such and such. Otherwise, it's class such and such. That's fine. Same thing if this is on Windows or if this is in a different place. But you should sort of only do those things for very global sort of things. You shouldn't do it based on an environment variable or something like that because you're just sort of inventing conditionals at that point. You should really do it as things that are properties of the systems that you might want to run on as a library, not sort of things that you invent on top of those things. So the way I try to think about solving this problem, or try to think about imparting a solution to this problem to people who really want to do the right thing, is that who here knows what if name equal main means? Okay, that's good. Who here does not know what if name equal main means? It's okay, you can admit it. Okay, well, okay. Very good for you. So lots of people when they get more involved in Python and start writing more complex apps, I think they forget about this feature of Python, which is to say that there is a very natural entry point to a program. It is inside the block that is prefixed by this if name equal main thing. And that is where code that is application code should go. Okay? And before that, there are two phases to sort of setting up a Python program. There are the things that happen before that block is reached. And then there are the things that happen as a result of that block being reached and inside that block. And basically, you don't want to do very much until you get to that second phase. Okay? You might not see this if name equal main if you're using a framework, but it's there somewhere. It's in a console script, or it's in there's some equivalent to I'm done importing things and now I want to start an application. You should make it easy for people to import your library, pull something in, and inside an if name equal main block, configure whatever they need to configure about your library and use it. Okay? If you do things in your library before that, if you read an environment variable, require that something be imported, things that are global, you are probably doing it wrong. Okay? For some definition of wrong, anyway. So what are the downsides of doing something like that? Well, one downside for in the case of multiprocessing, multiprocessing badly wants to implement the threading interface. It wants to be a drop-in replacement for threading. And the reason it's like it is now is because the reason we have that sort of mutation of module scope state is that that's what the threading module does. The threading module mutates global state. It sort of has to. That's, there is global state about threads in the OS. And there's global state about processes in the OS. But you could imagine a multiprocessing module that did not have the same API as threading does, but worked just as well. So there's a trade-off there, It's easy to teach, but it's harder to learn, So the same thing, well, there's a downside for logging. If you have more than one instance of a logger set up and they both use the same file, those streams might interleave, okay? There's not just one anymore, there's many of them. But in reality, there's been lots of times when I've wanted to just use the logging machinery that exists and not have it global. I just want a logging system for my application. I don't want to reuse the ini file config or any of that stuff. I just want to have my own little world going on. And the downside for MIME types is that you might need to reparse the system file or the Etsy MIME types file or whatever. These are all genuine downsides of this, but the important point of that is that if you do the inconvenient part, if you write the library in such a way that it exposes this less convenient API, you can always add the convenience on top of it. You can always add a module that sort of makes it not backwards compatible, but more convenient, and expose that to people, but also give them the option to use the less convenient but more general version. You can never do the other way. You can never do it the other way. You can never remove convenience from your API. It's impossible. Once you do that, you have to sort of rev it and make some new system. So here's a non-anti-pattern, a good idea. This is from the Schedule module, Schedule library class. And you can tell that this library author, by the doc string, someone said to him, you know, this class actually is sort of a cron-like class. You provided some time values and it does something every so often. And you can tell by whoever wrote this module and this doc string, someone said to him at some point, boy, this is hard to do. You know, boy, this is hard to set up. I wish it was more convenient. And he said, fuck you. You know? And it was the right decision, because someone can take this thing and they can do these 4 lines and make it more convenient, but you cannot do it the other way around. And that was the right decision under this system. So, you know, this is a quote from this guy who I see on like Hacker News and Reddit a lot. He seems to be a pretty clever guy. I don't know his real name, but he's talking about this sort of in the context of functional programming, but this applies to writing libraries. Basically, you want to take the stuff that manages state, you know, the things that you're trying to do at module scope and access databases and everything, and push it out as far as you can up until the if name equal main block. And try not to do any of that stuff for convenience's sake, and just make something that's very general. You can always add stuff later to it. It's better that way. Okay, so this is sort of more whinging about convenience stuff. It's better to avoid convenience stuff and add, you know, magical features. Wait until sort of the second rev of your library or some add-on package that does this, and sort of expose the inconvenient bits of it, like I said before, and I've already said this. Here's an anti-pattern example from Pylons, which in this example you can actually import a request object and a response object. And if you've done any amount of web programming, you know that requests and responses are not global. You have lots of requests and responses. You might even have more than one request and response going on at the same time. These are not logically global things. But at the same time, people like this pattern of importing them, and then inside of this controller, it goes ahead and does some magic under the hood when response.body is asked for, looks up the current response, and assigns body to it in that context. Flask does something similar. You know, it's almost exactly the same thing. It's got this proxy object that lives somewhere. I'm not sure if they offer response, but definitely request. So there are actually 2 problems with this. There are 2 levels of magic going on here. There's one level of magic which says, I'm going to offer you a object that is not logically global as something I can import globally. The other one is that there might be more than one of these things going on at the same time. Okay, so not only do you import something that looks very global, but it's not even like they're serialized in any way. You might actually wind up with 2 requests happening at the same time, so it has to use a thread local module or thread local variable. And it's very convenient in code to use this, but what happens is that code that is really not web related starts to depend on being able to import this stuff. It just happens naturally. You say, I need the request here. Well, you don't, but you import it anyway. You could just pass in some functions to the thing, or sorry, some arguments to the thing. But it's more convenient, definitely, to import the request here. And this, what happens is it makes testing slightly harder. Okay, it's not that much more work, but you have to understand more stuff about how the system actually works in order to test it. And usually, what that means is that people don't write tests. That's where it ends up, because it's too fucking hard, So a better idea would be to design a framework so its users, so that its functions receive a request argument and suggest to them that they pass derivations of the request around. You can always create another API. You can always add a library in there that says, look, I want that behavior back of importing the global, but just make it optional. It's not that hard. We can do that, but baking it into the library itself is probably not a great idea. So one concept that I want to whine about is that convenience doesn't mean cleanliness. I think when most people think about clean code, they think about the least amount of code they can type to do something really awesome. That is not what clean means. Clean means maximally useful in context that you did not predict. Clean means it behaves in a way that lots and lots of people can understand. So even though the code might be longer and it might not look as nice, look as pretty, it's going to be more useful in more contexts globally. Okay? So the idea being that strangers are going to want to use your code, and the more useful it is in places that you did not expect them to use it in, the better off everyone is going to be. And if you assume some execution context, web requests are always going to be served by a threaded web server. That's an assumption you can make, and it would remove a layer of complexity from your software if you made that assumption all the time. But it's not always true. People have async web servers that are not threaded. So, if somebody can use your library in a place where you're not where they don't have to think about that, it's more useful than it would be if they couldn't, even if it takes a little bit more code to get there. So, the third sort of rule is avoid knobs on knobs. A knob is a replaceable component in a framework or a library. And so think of a knob, you think of anything as a knob, but a debug flag is a knob. But also, someone offering you a way to subclass something and telling you that you can override this method is a knob. These are places to add in policy about what you're offering to people. Knobs are super useful. All frameworks are basically made of knobs, but the one pattern to avoid is sort of putting knobs on knobs themselves, and I'll show you an example of that. So in Pyramid, we have this authentication system that we configure through the use of an authentication policy object, and this authentication policy object is fairly complex. It has, maybe 4 or 5 methods to it that you need to implement if you wanted to make a new one of those things. And you set that authentication policy at the beginning of configuration. In the implementation of one version of an authentication policy, this auth ticket authentication policy, we allow people to pass in this thing called a group finder. The argument name is callback, but most people call the actual function a group finder. And what it does is it says, okay, I'm going to look up the groups for this guy too. All right. So if you notice, we're actually dealing with 2 separate frameworks here. I'm going to go back to the last slide. We're dealing with the authentication policy framework, which is expected by Pyramid, and then we're dealing with this mini framework, which is this auth ticket authentication policy framework that we've provided with this callback. And this confuses the heck out of people. when they look at it. They don't understand when to replace the big thing and when to replace the little thing. So what is the solution to that? Well, remove the knob. Don't do that. In this case, it would have been better if I had just let people subclass the auth-ticket authentication policy. It would have been just more understandable, I think, for people. So the fourth point that I want to bring up is that composing is often better than inheriting. And offering up superclasses just from the coding gods in a framework or library is often not a terrible idea, but there are often better ideas for that. Instead of using inheritance, you can typically use composition. That's usually a better idea, but as I just said, not always. I would have gone back in the auth-ticket authentication policy and made it an inheritance interface. But usually, most of the time, for the most part, composition beats inheritance. Now, what is composition? Okay. Well, let's take a look at what sort of problems we have with inheritance first. We have this thing that I looked up on Wikipedia, I guess. I didn't know what to call it, but someone has defined it as the yo-yo problem. And that's the problem you have when you have 10 editor windows open with all the code that it takes to produce that one subclass that you have. Who's had this problem? Okay. Yep. So that's a pretty awful problem to have. I mean, you don't know where the code is, you don't know where it lives, you have to keep a lot of state in your head. So here's an example from Zope. It has seven base classes. Yeah. Yeah. So which of those files is get item defined in? I don't know. 4 of them. Yes. Exactly. Yes. So the specialization interface of superclasses is awful easy to get wrong, and it's a pretty good example with Zope is that there wasn't a lot of documentation about how to subclass things. So people didn't really understand what they were allowed and not allowed to do inside of that system, and people overrode things that they couldn't override, and it was easy to get wrong. And when that happens, and you want to rev the framework, you want to bring the framework forward and sort of make it do other things, the superclass, or those things that you're inheriting from, they change. And when they change, they're going to break somebody, because they're going to break the people who didn't understand the implied contract. So that's a problem. So I'll skip this. This is more information about why that's bad. But here are some smells about if you're writing code and inheriting from framework classes, you might consider thinking harder about some of these things. Subclasses that override methods used by other inherited methods. So you override a method in a subclass, but that method is then used by the superclass. Is not, it is particularly when it influences state, is often kind of a smell. Things that use super, you call super and then you depend on what it does and then you do something else. Often there's probably a higher chance that you're going to misunderstand what the contract is when you're using things like that. I'm going to skip the last one. So what are the alternatives? Well, we have composition and event systems. So in a composition system, instead of telling folks to override a method of a subclass, we can tell them to pass in a component object. Does that mean 5 minutes without questions? And then 5 minutes, okay. Instead of telling folks to override a method, we pass in some behavior in the form of a function or another object of some kind. And so the interaction between the library code that you're using and your code is not performed, is not a function of inheritance. It's not you overriding some behavior that the thing gives you. It's a more formal contract between that library class and an object that you pass into it. And when you do that, the only dependency between those two things is the interfaces specified by the framework author. So presumably when someone does this, they have to tell you what the contract is. Otherwise, it just would not work. Okay? It is a way of keeping things honest about the division of labor between things. So here's an example of inheritance. We have a class that has a click and an increment channel thing. We have a click method. It does nothing. Okay? When we use it, we can override the click method and call increment channel if the button name is blue. So if somebody presses the blue button, it'll increment the channel. Easy enough. I'm sure lots of people have done things like that. Here's the composition equivalent of that. Instead of actually subclassing this TV remote thing, we're going to pass in a buttons object to its constructor. And the buttons object is going to be responsible for having its click method called. It's going to pass in the TV remote object to the buttons object, button object's click method with the button name. And here's how we use that thing. We make a buttons object instead of inheriting from the TV remote class, and we pass in an instance of that buttons object, and inside of the buttons object we have a click method that does that stuff. Okay, so it's another layer of indirection. That's basically what composition is. So when is it good to use composition? When is it good to use inheritance? Composition is sort of a take it or leave it sort of thing. If you know a problem domain very well, it is a good idea to use composition. If you understand all the things that people are going to want to do to use your library or framework, you should almost certainly be using composition because that should mean that you understand the interaction that you want to have with the consumers of your library. By definition, if you write a library, that should be true. You should understand what you're doing. Okay? But it's not always true, right? It's not always true in lots of valid cases. When you're writing an application for a customer or in your job or something, you're thrown into the domain where you don't know what the right thing is to do. It's often a bad idea to start out with composition there because it's harder, it takes longer, you might throw it away. It's sometimes just easier to do subclass. You can always replace it with composition later if you care, you know. But typically when you want to offer code that other people should use, composition is a good thing, and you know the domain. So I'm going to skip the event systems bit, and I'm going to take questions, I believe. Sorry, one more thing. When should you offer a superclass to people? Well, when the behavior of the thing that you're superclassing is absolutely fundamental to the instance of the thing that you're going to make. In ZODB, the Zope Object Database, there is a class called persistent. And persistent objects can be stored in the ZODB as a separate record. Any object can be stored in the ZODB, but these things are stored as a separate pickle, more or less. This is a framework bit. Very few people actually ever override methods of persistent. It is basically just something that gives Python objects persistence. You're never going to extend it very much. Things that are like Django class-based views that people offer to you that make things convenient do not have this property. They are not the same kind of thing. They are just sort of there for convenience, more or less. And I don't think that's a very good use of subclassing. That said, composition is harder for people to wrap their brains around, so I understand why people do it. People do it because it's easier to document. You can tell somebody just inherit from this class and it'll all be okay, you know. So that's when to do that. So we go over our guidelines again. Global state's precious. Don't design exclusively for convenience. Avoid knobs on knobs. Composition usually beats inheritance. And I will take questions now.
If you have questions, there's a microphone over here, and I got one here, so just line up either side. Anybody?
Can you ask me a question?
No question? Oh, you got one?
You can talk about the event Maybe you can talk about the events that
you
you
want me
didn't
to
get
go
to.
back? So an event system is just sort of a special kind of composition where instead of there being one entry point for people who are not you to specialize, if the system you're using sends an event, there can be a number of listeners for that event downstream. So like, let's say, in this example, you wanted the button press to not only change the channel, but dim the screen, but not everyone had screens that dimmed, more or less. You could send an event and then let people subscribe to that event and change state based on that event. So here's an example. I mean, this is obviously far more complex than the inheritance example, but you can make an event system, pass the event system into the TV remote instead of our buttons thing. And then the TV remote can call a notify method on the event system to send a message that the subscriber stuff can look for. And the point being there can be more than one subscriber to the thing. And people can register them arbitrarily, more or less. So this is handy in like web frameworks and stuff where you have to do something when there's a new request or something, or various well understood points in the handling of requests and responses. Is that good enough?
Hold on.
Good. Okay, is it on? Okay. So when using composition, I suppose I think of it as creating a contract between sort of the programmer that wants to modify it and the API, right? And so there are certain things that need to be fulfilled in that contract, certain requirements of behaviors and things like that. Say, for example, you're writing a greater than or less than comparison function, right? And you pass that in. Is there a good way of guaranteeing that entire contract is fulfilled regardless of what execution path might be used, so that you don't find out, oh, I thought I completed the contract, but it turns out that an exception was thrown because something wasn't quite programmed right or some behavior wasn't accounted for.
Yeah, well, it's a little tricky in Python because it's so dynamic. There's no, statically typed systems, you're going to know at compile time whether that's true or not. There are things like, the way I've done it in the past, and I'm probably behind the times on this. There's probably I think there's this trait system that I don't quite understand, that people talk about. But the way I've done this in the past is I'll assert something implements an interface, and then in my unit tests, I will make sure that is true. You know what I mean? So I will use the tests as the type system, more or less. You can write systems that before they try to execute, some component that got passed in, that you sort of do a sanity check on them. But I think most people don't because it slows things down. So I think it's mostly, sort of endemic in Python that sort of, okay, this might fail at runtime, more or less. And I haven't seen a great way for folks to absolutely, for honest to God, for sure, without a static type system, make sure that this thing's going to work if I pass it in. It's mostly down to testing, I think. Yep.
Actually, folks, it's time. The session's ended. If you want to ask a few more, come on up. But otherwise, enjoy your lunch. And thanks, Chris. There we go. All right, we have Chris McDonough here. He's going to talk about API design for libraries. Chris.
Hello, everybody. Wow. Did somebody pay for that?
You will later.
I will later. All right, so my name's Chris McDonough. I am a consultant at a consulting company named Agendaless Consulting in Virginia. And I'm going to talk about API design for libraries. This talk is just mostly going to be me ranting about bad design, more or less. But I hopefully, I don't mean to to rant entirely, hopefully you get some useful information out of it. So I came to Python through Zope in about 1999 or so. I've authored the Pyramid Web Framework, Supervisor, Unix Process Controller, and a bunch of other of my own code and seeing other people's code. If you follow these guidelines, hopefully your code will be useful to strangers, not just the people who sit next to you or the people you talk to on IRC, or people who actually need to use your code who do not know you, don't know your name, don't care who you are. This is the point of this talk. And the importance of these guidelines increases with the social distance that you have from those people. So these things aren't all that important when you're sitting next to the person using your code, but when you're not sitting next to the person using your code, they can be important. So here are the guidelines. The first one is global state is precious. All right? Global state is module scope state in a Python program. The second one is don't design exclusively for convenience. Third one is avoid knobs on knobs. And the fourth one is composition usually beats inheritance. And I'm going to talk about each one of these things. So the first one we'll talk about is global state. What you're going to want to do when you write a library is you want to avoid unnecessary mutation of global state. Mutation of global state happens when you type something at module scope in a Python module, and that module gets imported or executed. So a class statement or a function statement is actually a mutation of global state. You're changing the state of the Python process by doing that. But when you require that other people mutate global state in a way that they wouldn't normally to use your library, or when you depend on reading some global state in your library that they wouldn't otherwise have to read, it sort of becomes less of a library. It's more like an application. And we'll see some examples of this. So one example of this is in the multi-processing library, in the things that I'm less proud of. And so I'm going to give this talk, and I just want people, I'm sure I'm going to step on somebody's toes during this talk. I don't mean to do that. I care about your feelings. How can you tell I'm lying? And if I use code for one of your projects, doesn't mean actually it means I use it. So it's it would be worse if I didn't. So I'm going to talk about three kinds of things in this talk. Well, this talk is mostly about libraries, but there are three different kinds of things that have strangers using code that you might write. One is an application. And an application is something, in my mind anyway, for the context of this talk, an application is something that can use global state with abandon. A database is global state, okay? Module scope stuff is global state. A framework is sort of a step down from that. It doesn't have, usually frameworks have no state, but they call into code. You provide them callbacks that they call into, okay? A library is neither of those things. A library is something that you call in order to have it do something on your behalf, all right? Usually libraries maintain little or no state. They're not stateful, they're just sort of tools. And they don't have any callbacks. This talk is mostly going to be about libraries, although I'm going to probably venture off into framework land at some point. So the things that I'd like you to take away from this talk are 4 guidelines. These are things that sort of, I think are important. They're not the only things you need to know about API design, of course, but they're sort of bred from annoyance on my part